I hope all of you are doing good. Let's start today's chapter, Exponents and Power. After reading this chapter, you will be able to know about all these topics. So let's get started. Introduction. Do you know diameter of Earth is 1.2756 into 10 raised to the power 7 meter. The diameter of the Sun is 1.4 into 10 raised to the power 9 meter. If we write this in expanded form, then expanded form of this is this and expanded form of this is this. We know that to write such large numbers more conveniently, we make use of exponents. For example, 10 raised to the power 9 is read as 10 raised to the power 9. Similarly, this is read as 3 raised to the power 9 and this is read as a raised to the power n. In these numbers, 10 raised to the power 9, 3 raised to the power 9 and a raised to the power n. 10, 3a, these are called bases, and 8, 9, 9n are called exponents or powers respectively. So these are written in exponential forms respectively. Okay. Powers with the negative exponents. See, we know that 3 raised to the power 2 is 3 into 3. But 3 raised to the power minus 2 is what? 3 raised to the power minus 2 is 1 by 3 raised to the power 2. That is 1 by 3 into 1 by 3. That is 1 by 9. Right? 10 raised to the power 1 is 10. 10 raised to the power 0 is 1. And 10 raised to the power minus 1 is 1 by 10. Okay? And 10 raised to the power minus 2 is 1 by 10 raised to the power 2, that is 1 by 10 into 1 by 10, that is 1 by 100 and so on, right. So in 3 raised to the power minus 2, see, this is the base and this is what? Exponent. 2 raised to the power minus 2, this is base and this is exponent, or you can say power. And 10 raised to the power minus 2, 10 is base and minus 2 is exponent. Okay. Following the pattern in 3 raised to the power minus 2, 2 raised to the power minus 2 and 10 raised to the power minus 2, we can say in general that for any non-zero integer a raised to the power minus m is what? 1 upon a raised to the power m. Okay, where m is a positive integer. Also, a raised to the power minus m is called multiplicative inverse of a raised to the power m. So, multiplicative inverse of 5 raised to the power 2 is a 5 raised to the power minus 2, and multiplicative inverse of 7 raised to the power minus 2 is 7 raised to the power 2. Right? Now, laws of exponents with integral powers. 1. If x and y be any rational numbers, that is non-zero, and m be any integer, then, okay, let's have a look. X raised to the power m into y raised to the power m. Okay, so what you see here, exponents are same but bases are different. So we will multiply the base and exponent will remain same. Okay, x raised to the power m, y raised to the power m is what? X by y raised to the power m. Okay. 2. If x and y be any two non-zero rational numbers and m and be any integers, then x raised to the power m into x raised to the power n is what? See, now the base is same but exponents are different. And this is multiplication, so we will add the powers. Okay, but if there is a sign of division, then we will subtract the powers. Okay, and x raised to the power m raised to the power n is what? X raised to the power mn. Okay, and x raised to the power minus m is equals to 1 by xm, and if x raised to the power is 0, 1 is the answer for any non-zero value of x. Okay, now let's do example 1. You have to express the following powers of rational numbers as rational numbers. Okay, minus 3 by 4 raised to the power 3. Okay, minus 3 by 4 into minus 3 by 4 into minus 3 by 4. 3 3s are 9, 9 3s are 27, but minus 4 4s are 16 and 16 4s are 64. Next is 3 raised to the power minus 4. 1 by 3 raised to the power 4. Okay, now we will write it 4 times. 1 by 3 to 1 by 3 into 1 by 3 into 1 by 3. Okay, so 1 into 1 is 1 only. 3 3s are 9, 9 3s are 27, and 27 3s are 81. Okay, third part you will do. Okay, next, example 2. Simplify and write the answer in exponential form. Okay, minus 1 by 32. Okay, how can we write it in exponential form? You know that 32 is 2 into 2 into 2 into 2 into 2. That is minus 1 by 2 raised to the power 5. Okay, example 3. Simplify. 3 raised to the power 1 plus 6 raised to the power 1 divided by 2 raised to the power 2 by 3 raised to the power minus 2. First, 1 by 3 plus 1 by 6 divided by 3 by 2 whole square. Okay, now let's take the LCM. 6, 2 plus 1 divided by 3 raised to the power 2. Okay, now what will you get? 3 by 6 divided by 3 raised to the power 2. Okay, now 3 raised to the power 6 divided, you can do it, multiply 2 by 3 raised to the power 2. Now 3 by 6 into 2 by 3 into 2 by 3. 3 goes, 2 3s are 6. Okay, so 2 by 9. This is your answer, right? Okay, let's do exercise 12.1. Evaluate 4 raised to the power minus 2. 1 by 4 raised to the power 2. 1 by 4 into 1 by 4, or you can, no need to write it 2 times, you can do it orally also. Okay, 4 into 4 is 16. So 1 by 16 is the answer. Okay. Use of exponents to express very large and very small numbers in standard form. It is easy to remember small numbers like 45 kg, 200 centimeter, or 5 feet 6 inches, etc. On the other hand, there are numbers which are either very large or very small and can't be remembered in the given form. For example, the size of a plant cell is this much small, or the thickness of a piece of paper is this much small, that is 0.0016 centimeter, or distance of Earth from the Sun is this much, height of Mount Everest is 8,848 meter, and many more. So we can express these very large or very small numbers in standard form and memorize them. For example, we can write this as 1.75 into 10 raised to the power 9. We can write this as 2.575 into 10 raised to the power 12. We can write this as 8.5 into 10 raised to the power minus 8. Okay, and we can write this as 1.6 into 10 raised to the power minus 5. Okay, let's do the example. We have to express the following in standard form. Okay, so this is the number 4, 1, 5, 2, 1, 2, 3, 4, 5 zeros are there. Okay, so we always put decimal after first digit. Okay, 4.152. Okay, now 10 raised to the power how much? See, 1, 2, 3, 4, 5, 6, 7, 8. 10 raised to the power 8. Okay, and next is 0.00. How many zeros are there? 1, 2, 3, 4, 5, 6, and then 4, 1, 5. Okay, so where will we put decimal? After 4.15 into 10 raised to the power. Now see, we are going towards right side, so we will put a negative sign with the exponents. Okay, 1, 2, 3, 4, 5, 6, 7. So 10 raised to the power minus 7. And in example 5, we have to express these numbers standard form in usual form. Okay, so there is 3.72 into 10 raised to the power 5. So 372, and how many zeros we will put here? 1, 2, 3. Okay, now let's do exercise 12.2. See, you have to express this in standard form. So 2, 4, 1, 5, and then there are 6 zeros. 1, 2, 3, 4, 5, 6. So 2.415 into 10 raised to the power how much? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 raised to the power 9. Right, students? Okay, now I hope you have understood this chapter, and now you will do practice of the remaining exercises. Okay?